In this video, we are going to prove the weak law of large number. First of all, we need a tool, that is the Chebyshev inequality. Basically, the Chebyshev inequality states that the probability that the absolute value of x minus the expected value of x is larger than an arbitrary number a is smaller or equal to the variance of x divided by a squared. Now we are going to prove the weak law of large numbers. First of all, imagine that we have a sample made of x1, x2, so on till xn, and those variables are random variables and they are identically independently distributed. So all these variables have the same expected value and variance, and we call it the expected value of x is mu, while the variance of x is equal to sigma square. So what we are going to do, we are going to substitute this argument here and here. So we substitute the x with the sample average that will be equal to the x bar that is equal to the sum divided by the number of observation. So the weak law of large numbers states that this quantity will converge in probability to mu. So how we prove that? So we take the Chebyshev inequality and in the place of x we insert the sum divided by n. So we calculate the probability that the absolute value of the sum divided by n minus the expected value of the sum divided by n is larger than delta, then this will be smaller or equal to the variance of the sum divided by n divided by delta squared. So what are we going to do? First of all, we have to compute the expected value of the summation divided by n, and then compute the variance of the sum divided by the number of observations. So first of all, we compute the expected value of Sn divided by n. We take out 1 over n. So we take the expected value of the sum times 1 over n. Then we split this the sum and we show that is equal to x1 plus x2 plus until we go to xn. So since they are all independent and identically distributed, then it will be equal just to n time mu divided by n. So the expected value of the sample average will be just mu, while the variance of the sum divided by n, we take out the square of 1 over n and we multiply it by the variance of s, that is the sum. So we have that this multiplies the variance of x1 plus x2 plus all the other observation. But since we are in the case of independent random variable, the variance of the sum will be equal to the sum of the variances. So we have that n times sigma is the variance of the sum divided by n squared, and then we are left with sigma squared divided by n. Now we take those values here and we take it into the formula of the Chebyshev inequality. So what we are going to do is to compute the probability that the absolute value of Sn minus mu is larger than delta will be smaller or equal to sigma squared divided by n times 1 over delta squared, as we stated here. So we took the variance, we took this variance here, and we put it in this place. Now, Since we are talking about convergence in probability, we have to compute the limit as n goes to plus infinity of this probability, the probability that this difference is larger than delta. But we can factorize again this stuff, and we have that 1 over n multiplies sigma squared over delta squared. So what happens when n goes to infinity? It obviously goes toward to 0. So we have that the limit, the probability limit of this stuff is equal to 0. For this reason, we might say that the sample average converge in probability to mu. And we are concluded.